This lesson revisits sequences and series. We're now going to look at the second main type of sequence and series in Core 2, geometric sequences and series. So looking at this sequence here, where we add 4 to get from any term to the next term, as we well know, this is an example of an arithmetic sequence containing a common difference to get from one term to the next. Here, to get from one term to the next, we're multiplying the current term by 4 to get to the next term. This is what we call a geometric sequence, where we have a common multiplier, which we refer to as a common ratio. So a general inductive definition of this form: the nth term times r gets us to the n plus 1th term. So the number multiplied by each time, which we refer to as the common ratio, and usually use the letter r to signify. So we can define this sequence here with a first term of 3 and an inductive definition of 4un. So un plus 1 equals 4un. We can use this definition to generate terms. So u2 is u1, 3 times 4, and so on. And we can use this as our nth term formula. Our first term, u1, times 4 to the power of n minus 1. The first term times the common ratio to the power of n minus 1. So in general, un equals u1 times r to the n minus 1. You will often see this written as a instead of u1. So a times r to the n minus 1. So to work through some examples, to find the 20th term of the sequence 2, 6, 18, 54, well, let's put down what we know. We know that the first term is 2, and we can work out the common ratio. We can see that we're multiplying by 3. We could do this by dividing 6 by 2, or 18 by 6, or 54 by 18. If you divide any term by the previous term, you will find the common ratio. We know that n is 20, so to find the 20th term we use that nth term formula. un equals u1 times r to the n minus 1. This is in the formula booklet. Stick some numbers in: 2, 3, and 20 minus 1, 19. And we'll get this number here. It's not unusual with geometric sequences because we're multiplying. We're starting to incorporate multiplying to powers to get very big numbers quite quickly. Okay, a second example. This time we want the nth term of the sequence, so we're not going to get a number this time, we're going to get an nth term formula. Well, we can see what the first term is. We can work out the common ratio. You can see here we're going down, so the common ratio is going to be fractional. So if we divide 7.2 by 18, remember you can always get it by dividing a term by the previous term, we get 0.4. So the nth term formula is 18 times 0.4 to the n minus 1. And we can't do any more than that. We have our rule for the nth term. Okay, your turn. Try and work this one out. Might need a little bit of thinking about. If you can do this, then you're well prepared for the lesson. Pause the presentation. If you're struggling, I will be giving step-by-step guide through it, but try and answer it just from here. Okay, remember the golden rule with these sequences and series, write down what's written. So the third term is 15. Well, you know what the formula for the nth term is, so write it down for the third term. So 15 equals u times r squared, because remember it's r to the n minus 1. 375 equals u1 times r4. And you can probably now see how you can work it out. If we divide these, we get 375 over 15 equals, well, this is going to cancel down. The u1's cancel, the r squared goes into r to the 4, and we just get r squared. Equals 25. There's 25 15s in 375, so r equals 5. To find the first term, the third term, 15, is u to the 1 times 25, so u1 equals 15 divided by 25, which is 0.6.